Well, if wave is particles, what you will see is this that you can see. In other words, the light either makes it through the slit or it doesn't. And with those two slits, you'll just see bright slits behind where the slits in the screen are. Remember? So, geez, I'm thinking like a long stick. This is our glass, painted black with slits. This is just like a piece of index card or paper or something like that. And we're going to see, are there bright spots on here caused by the light or aren't there? Well, if light is particles, this is what you'll see. That is to say, the light either makes it through the slit or it doesn't. And you'll get two bright images of slits on your viewing screen right exactly behind where the actual slits are. That is to say, the light made it through there or it didn't make it through at all. One of the two things that happened. So it's dark everywhere but where the two slits are. That's just like the particle. Or you might see something like this with a whole bunch of different bright spots. Why would you see such a thing, you may well ask? If light is in fact a wave, then it's going to do the same thing as described above before. That is to say, when the light goes through either one of the slits, it's going to bend. If the slits are somewhere in the ballpark of the size of the wavelength of light. Again, it can be within a factor of like 10 or possibly 100. But if you're more than that away, you're not going to see any fraction at all. Any diffraction at all. So I won't bend around any space. So, that's what we got going on here. We've got the light. As it comes through both of the slits, it diffracts. It basically turns it into circular waves. Now, here's the deal. Some places, the crest of one circular wave overlaps the crest of another circular wave, and you're going to have constructive interference. The two crests will build on each other. Other places, you're going to have the crest
Cancel each other.
you're going to have the crest from the top slit and the trough from the bottom slit on top of each other, and they'll cancel each other out. Now, there's a better picture of this coming up. But this is just kind of a general description of what's happening. This is how they actually interfere. In other words, in this first one, you've got basically a single light source back here, such that there's a crest from the wave that makes it through the top slit and the wave that makes it through the bottom slit. There's a crest in both slits right at the same time. Now, if you look at those two making it to some midpoint, you should still have a crest on a crest. Why? Because, let's for instance, in this case, there's 1, 2, 3, 4, 5, 6, 7, 8 full wavelengths.